Hey guys, welcome back to my channel called How To. In this, I'll just demonstrate how we can configure route-based VPN. Okay, uh, using GRE, right? So GRE stands for Generic Routing Encapsulation. That I have already plotted a video for GRE, right? So without wasting much time, I'll just configure first a GRE, okay, quickly, and then I'll tell you the purpose here. Okay, so let's configure the GRE first, and then we'll achieve our what are the drawbacks that GRE have and why we are using to improve those drawbacks, what we can do. So just to demonstrate what I'm gonna do, I'll just quickly configure the GRE, okay, and then what I'll be doing, GRE just provided encapsulation, right? It doesn't provide any security, right? So for achieving those security parameters, I'm gonna use IPSEC over GRE, okay. So let's roll in. So I'm in R1 right now. I have so this is my public network, okay, between R1 to R3. It's my public network, right? So let's quickly jump in R1. I have configured a default route pointing towards ISP. R2 is my ISP. From R3 as well, I have configured a default route. So I do have an full connectivity between public network. I'll just ping routers R3 IP address. That's 23.1.1.3. See, I have, right? So IP route. Okay, so IP protocol, I'm not using any protocols right now. Okay, so config T. I'm going to configure the GRE first. Let's get the tunnel first. So interface tunnel 10. I'm going to use 193.168.20.0/24. Okay, so this would be the network I'm going to use for my tunnel interface. Okay, IP address 20.1.0. Okay, and the tunnel source would be public IP address of my R1, that is 12.1.1.1. Tunnel destination is 23.1.1.3. It's taking time. Okay, so additionally what you can do, you can even define tunnel key. Okay, tunnel key if you want to, right? You can define any number for tunnel key, but I'm not using anything as of now, right? So what I have done, I have configured tunnel 10 over here, right? And I'll quickly jump into R3 and I'll configure the same, right? Config T interface tunnel 10 IP address 20.2.255.0, and then tunnel source should be 23.1.1.3. Tunnel destination is 12.1.1. Okay, exit. So what I'll be using, EIGRP for advertising my loopback interface. Okay, the goal here is my loopback interface, R1's loopback interface, uh, should be able to reach out to R3's loopback interface, right? Not from here. Logically, we're gonna have a tunnel, right? And from tunnel interface, we'll achieve our connectivity, right? Check out my GRE video for a bit for getting the more clarity on this. So I'll quickly go on R1 and configure EIGRP 10 no auto summary. I'll advertise my loopback interface network, that's the 1.1.1.0, right? And I'll advertise my um, tunnel interface, that's 193. I'm not gonna advertise this public network over my EIGRP network 193.168.20.0. 20.0. Okay, and then exit, right? So jump into R3. Do the same router EIGRP 10, right? No auto summary network my loopback interface 3.3.3.0 network tunnel interface 20.0. As soon as I hit the I'll just hit the enter. Okay, you'll see my neighborship will come up. Okay, because I'll be advertising my loopback interface, right? I'll be advertising my tunnel interface IP, not the loopback. So hold on a second. See, as soon as I provided the tunnel interface IP, my neighborship is up. Okay, so IP EIGRP neighbor. So the neighborship is up, right? And from which interface? From tunnel interface, right? So the goal here. Okay, so what so IP route? Okay, for reaching out to 1.1.1.1. Okay, my next hop IP would be 20.1, right? That's my R1's and the tunnel interface of R1, right? And from which tunnel? From tunnel 10 that we have created. Okay, so let's try if we can ping 1.1.1.1 from source interface loopback 0. Okay, so we have an reachability, right? So interface tunnel. So interface tunnel 10. Okay, so so this is my tunnel, right? The protocol is up, and what else we can see? The address. Okay, and the encapsulation is the tunnel, right? It's like the default encapsulation mode for GRE. Uh, right now it's in tunnel mode. Okay, and I think we can even change this tunnel mode to transport mode. Uh, just to let you know, config T interface tunnel 10 tunnel mode, right? So I think from here you can change the mode as well. That's a different one we're gonna cover later. What I was showing is so IP so interface tunnel 10. Okay, what else I want to show you is, see, okay, so the tunnel protocol, right? What we are using is a GRE, right? The tunnel protocol and the transport that we are using is GRE/IP, right? The transport protocol is our IP and the tunnel protocol is our GRE. Okay, now our tunnel protocol is GRE. As we know, GRE is not that secure, right? It doesn't provide the security, it just provides encapsulation. Okay, so what we can do is to achieve, if you are using GRE, right? And if you want to achieve security for the traffic passing through that tunnel, you need to use IPSEC. Okay, you can use IPSEC over GRE. Okay, so this is the main agenda of our lecture, right? Now I'll just create a checklist first. What we need to, like you know just hold on a second. The checklist should be just to take the things into consideration, right? I'll just create some steps, the mandatory steps that we need to follow. Okay, keep it as a note for the reference. I don't know why it's giving. Okay, so the first part is, so we are using route based VPN. Okay, so we what we used to do in IPsec VPN, for policy based VPN, we have the lab, right, already. So we tend to use ACLs, right? We create ACLs, right, and crypto map and so on and so forth, right? The phase one tunnel, phase two tunnel, and binding it to the crypto map and finally to the interface. So here in policy based VPN we don't use ACLs. Okay, what no ACL is required. um, it's it's my it's lagging somehow and I'm not sure why. Okay, one, no ACL is required. Okay, so what we're gonna do, we're gonna create the ISCAM policy. Okay, ISCAM policy is required, right? Third step is we need to have crypto map key. We need to define a key, right? Define a key that we have done, right, in policy based VPN the same way. So we need to define transform set as well. Transform set is required. Okay, 5. The step 5 would be no crypto map. Okay, we won't be using any crypto map over here. Step 6 would be instead of crypto map, we're gonna use IPsec profile. Okay, step 7 would be, and once we'll create our IPsec profile, we can use our tunnel protection. Okay, so we're gonna protect our tunnel with our IPsec profile that we're gonna create. Okay, so lastly what we'll be doing, we're gonna bind our profile to the tunnel. That's how we'll achieve our um, security. Okay, so let's roll in. Okay, I'll just quickly jump into R1. um, okay, I'll just quickly jump into R1. So no ACL is required, but what we need a size scan policy. So crypto create a scamp policy. Crypto as scam crypto as scam policy. Okay. So give it a number like 10, right? So what are policy? As scam policy Hegel, right? HEGLE. Hashing I'm gonna use MD5. Authentication I'm gonna use preset key. Group I'm gonna use 19. Lifetime I'm gonna leave it as default. And encryption I'm gonna use, I think, 3 days. Okay, so the same thing I'm gonna configure on R3. Okay, let's roll in R3. Config T. Okay, crypto scam policy 10. Okay, and hashing MD5. Authentication preset key. Group I'm gonna use 19. Lifetime I'm gonna leave it as default, and encryption would be 3 days. Okay, keep in mind these policies should I'm sorry. Keep in mind this policy should be symmetrical across both the routers. Okay, and symmetrical means identical. Okay, if you're gonna mismatch the configuration for the phase one tunnel, that's called scamp, the phase one tunnel that we are creating just now, right now, it should match. Okay, it should be identical, else your tunnel won't come up. So encryption is done. HGLE. Oh, I think it's done, right? So what next? So our checklist says scam policy is required that we have created. Now define a key. Okay, configure in here. Okay, now crypto scam key. Now define a key. Cisco and the address. This is the Cisco is my key for remote address 23.1.1.3. Okay. Similarly, go on R3. Okay, and define a key. Crypto scam key. 20, so I'm in R3. It would be 12.1.1.1, and sorry, key would be Cisco, and the address should be 12.1.1. Okay, okay. Come back here. So what next? We need to define a transform set. Okay, so define a transform set. Define transform set. Okay. Now, for defining a transform set, the command would be um, crypto transform crypto IPsec transform set. Okay, the phase 2 tunnel. Crypto IPsec transform set. Give it a name called anything. I'll give it as T set. Okay, and I'm gonna use ESP. I'm gonna use ESP as 3 days. Okay, and I'm gonna use for encryption at Mac ESP MD5 at Mac. Okay, the choice is yours. What parameters you gonna use for encrypting the phase 2 tunnel? Okay, for providing for hashing and for encryption, what you need to use, that's all up to you. But make sure, like this should be identical on both the side. Okay, the parameters should match. So go on R3, go on R3. I'm gonna paste it. Okay, so it's done. We have configured our transform set as well, right? So what next? We gonna so there is no crypto map, right? We won't be using any crypto map, right? Sorry. Instead of crypto map, what we gonna use? We're gonna use the IPsec profile. Okay. So go on R1. Um, crypto IPsec profile. Give it a name. I'll give it as IPsec PROFILE IPsec profile. Right. Now, what you can do? Call your transform set. Set transform set as t set. This is the name of my transform set, right? Set transform set as a t set, and I think that's all. Okay, if you want to give the description, you can give it, and rest, I think nothing more. Okay, so I'll just come back. I'll go on R3. What I'll do, crypto IPsec profile. I'll give it a name, IPsec profile. Okay. Um, you can give it a different name as well over here. Okay. This won't affect. It can be asymmetrical as well, right? And the crypto IPsec profile, call out to your transform set that you have just created. Set transform set as t set. Okay. Now come out. So let's see what we have. So crypto assay. So crypto ISCAMP security associations. We don't have anything right now, right? Now what I'll be doing is, so crypto, do you have anything? So crypto. No. Now, like, so what our last last thing that we need to do is tunnel protection, right? So we have done our all the checklists that we have created from 1 to 6 we have done, right? So that the final part would be, I'm gonna uh, so all these things, right, are covered and are consolidated under this IPsec profile. Now we're gonna use this IPsec profile, right, just to in our tunnel that we have created, okay, just to protect our data, right, our traffic. So bind it to the tunnel, right? So I'm gonna use the command interface, go in your tunnel interface that you have created, interface tunnel 10. Okay, tunnel protection, right? Tunnel protection IPsec profile. So what's the name of a profile? IPsec underscore profile, right? So I have binded my that profile to the tunnel interface, right? Now see what's happening here, right? We got a log, right? See, our neighborship is down right now. Why? The reason being, right, like I haven't applied the profile to in routers in router R3, right? I have just applied this profile to on my routers R1, right? So see, um, So the received packet is not an IPsec. So the router is receiving some packet, have received some packet from R3, but it says it's not an IPsec profile, right? Because we have already applied IPsec profile in our router, right? But it's not applied in the other hand. So even you can see the port number 47, right? So the port number 47 is in GRE. So the packet we have just received was GRE, and so the reason being there is a mismatch, right? So our EIGRP neighborship is going down. I think it's down now. Okay. So so I so IP EIGRP neighbor. See, I don't have any neighbor. So IP route. Okay, I haven't learned any route from EIGRP, right? So so crypto assay. So crypto scamp assay. See, um, here, like scamp assay, right? For destination this and from source this, my connection status is active, but the state is in no state, right? And this is wrong, right? We should be having some QM and QM underscore idle, right? So the state is wrong here. Okay, so if I'll go on, okay, also one more command. So crypto IPsec assay. um See, okay, for this, it is just pointing like now what's our tunnel, right? I'm like the tunnel that we are using, the local address, right? And the local and remote identifier, right? And the current pair is our 23.1.3, right? But there is no any packets, like there is no any packets encapsulated, encrypted, right? And no any digest was created and verified. Okay, so this is all zero. Reason being, like our IPsec, the profile we have binded on this end, we haven't binded into other end. So the there is no traffic flow. Okay, so we have sent 28, so there are 28 errors, right? So we have sent something but we haven't received. Okay, if you again hit so crypto IPsec assay, this count will be increasing. Okay, because from my end I'm trying to send something but I'm not receiving. So this is a sending error, right? Still see, we are receiving this thing, the message, okay, from port number 47, protocol number 47. Now what I'll do, I'll quickly jump into R3, okay, and I'll bind our profile that we have created, okay, into the tunnel. Config T, interface tunnel 10, okay. Tunnel protection is our tunnel protection IPsec, right? The profile that I'm gonna use is IPsec underscore profile. Okay. Now, if you'll see, my neighborship is up, right? EIGRP neighborship is up. Okay. So IPsec, sorry. So IPEIGRP neighbor, right? I do have a neighborship and that is up, right? So IP route, I do have a valid route for reaching out to loopback interface of R1 from source from loopback 0. Okay, right? Now show crypto IPsec assay. Now see, packet are being sent, right? Encapsulated, encrypted, and for the packet digest are being created, and it's being also verified, right? And what else? uh, so these are inbound and outbound SPIs and all I have already covered, right? So the thing I would like to show you more is so crypto scam assay. Now see, previously the state was something else, right? It was not in idle, right? So right now we have a quick mode in idle state, right? Our our scamp assay parameters are in good state, right? So what else I can show you is, so crypto map. Okay, see, the point here is, look, we haven't created any ACLs, right? We haven't defined any ACLs by our own, right? But and also crypto map, right? But when you look into this, so crypto map, see, there will be one um, a crypto map and the ACLs created by the router itself, right? See, we don't have to define a manual ACL, and we don't have to define a crypto map over here. What we'll be doing, we'll just be creating one IPsec profile, right? And we're gonna call out, right, in this profile. That's what we are doing that's what we are doing, right? So the logic here is, what you need to understand is, look, we haven't created any crypto map, right? It is created by default by the router. We haven't created any ACLs, but the ACL is already created by the router, right? So what does ACL says, right? And so the access list permit GRE host from this to this, right? So for any GRE traffic, the ACL is created by the router, right? And what prod transform set we are using, right? This, okay, and the tunnel that we are using, right? Okay. Um, so interface tunnel 10. One more thing I would like to show is, um, now there is internal protection. Okay, so the tunnel is being protected by IPsec, and the profile that we are using for protecting this tunnel is IPsec profile. Okay, and use our IPsec profile under the GRE tunnel that we have created, right? Just to achieve security. Okay, so I hope this video is informative for you, and so we have done our lab. So the mode is GRE IP, right? uh, and what we have done, over the tunnel that we have created, we have used our IPsec profile just to achieve the security, right? So I hope you'll do the lab, and came out with any sort of questions or confusions. If you have, do let me know in the comment section below. And thank you so much for watching. See you until next time.